going to look at writing polynomials from zeros. Zeros or roots, they're the same thing, are where that's the location on where your function crosses the x-axis or the solution to a problem. There are certain pairs that belong together. So back in Algebra 1, we worked a lot with the quadratic formula. Those answers that we got out of the quadratic formula were zeros. Those are solutions. And so certain things come in pairs because of that plus or minus symbol. If I end up with a zero, that's a square root of 5. Well, I also had to have that negative square root of 5. Same thing, so here's the examples at the bottom that I'm referring to. If I have a 1 plus square root of 7, it has to have that minus square root of 7. They have to come in pairs. If I have an imaginary number, so square root of a negative number, right? Again, it came from taking a square root, so it has to have that pair. And then the last example we have here is the 2 plus 14i has to come with 2 minus 14i. That imaginary piece, or wherever the square root happened, has to have both a positive and a negative as part of its zero. So if we're looking at zeros, like we are here, we need to be able to identify that if I have a square root of 3, that I should also have a negative square root of 3. They both need to be there. So even though I was only given 3 zeros, we need to be aware that there are actually 4. So mathematically speaking, a 0 comes from, let me take the 2 for example. It's our solution being that x is equal to 2. But I want polynomials here. I put 0, sorry. X is equal to 2. If I wrote that as a polynomial, I would move the 2 back over to the x, and I'd get x minus 2 is equal to 0. This is the piece that we need. This is our polynomial when it is 0, which is where we get our solution from. So when I write out the new polynomial, sorry, I erased my negative. My x is actually going to be x, I guess I put minus, well, plus, whatever, it doesn't matter on that one, x plus 0 times a positive square root of 3. I would subtract it to the other side, so I would get x minus square root of 3. The 2, we just did that, that was x minus 2. And then my negative square root of 3 is going to be added to the other side. So we get x plus square root of 3. Okay, these would be all the polynomials that are going to give us our final solution. So we're just going to multiply all of these pieces together until we get what we're looking for. I highly, highly recommend starting with any pairs that you have. So we had the square root of 3 and negative square root of 3. Those were our pairs. So something special happens when you multiply these pairs together. So I'm going to create a 2x2 box because I have 2 binomials. And I'm going to multiply x plus the square root of 3 and x minus the square root of 3. Okay, so just some quick multiplications. So we have x times x is x squared. I have x times negative square root of 3x is negative square root of 3x. Positive square root of 3 times x is positive square root of 3x. And then square root of 3 times negative square root of 3 is negative square root of 9. Okay, so putting all of this together, I get x squared. Positive square root of 3 plus a negative square root of 3 is 0. These cancel each other out. That's why we started here. And then minus the square root of 9. Well, the square root of 9 is actually just 3. So we get minus 3. So coming back over to our blue equation, x plus 0, that's just x. Okay. Our next set of parentheses, we multiplied the square root of 3's together and we got x squared minus 3. And then we still have x minus 2. So next we're going to multiply these 2 binomials together. So another set of multiplication. I'm going to draw another 2x2 box. We're going to have x squared and a negative 3 and x and a negative 2. X squared times x is x cubed. X squared times negative 2 is negative 2x squared. Negative 3 times x is negative 3x. Negative 3 times negative 2 is a positive 6. Putting all our like terms together, we get x cubed, that's our only x cubed. Negative 2x squared, that's our only x squared. Negative 3x is our only x, and plus 6. So that would be our new polynomial after multiplying those. So back to our blue equation, we get x times the new result, which is x cubed minus 2x squared minus 3x plus 6. And then finally, we're going to distribute that negative into the polynomial. Okay, so each thing is going to get multiplied here. So we end up with x times x cubed is x to the 4th. X times negative 2x squared is negative 2x cubed. Negative 3x times x is negative 3x squared. And then x times 6 is a positive 6x, which is the final answer for this problem. Okay. One more example for us today. We have 2i, 2, and a multiplicity of 2. That means that whatever had that multiplicity has 2 of those answers. So we really have a positive 2i that comes with a pair of negative 2i. We have a positive 2 that has a multiplicity of 2, so there's another 2. Okay, it has two 2's. So as our factored form, our polynomials, the positive 2i becomes x minus 2i. The negative 2i becomes x plus 2i. The positive 2 becomes x minus 2. And the other one is also x minus 2. And we're just going to multiply all of these together. So first 2, I'm going to multiply. That's going to be a 2 by 2 box. So I get x and a negative 2i, x and a positive 2i. Multiplying these together, again, please pause the video at any time so that you can try these problems. X times x is x squared. We get 2ix, negative 2ix, negative 4i squared. Putting together our like terms, these cancel. So we get x squared, and then negative 4 times negative 1, so plus 4, right? And remember, I squared is equal to negative 1. So we get negative 1 times negative 4, which is positive 4. So for this polynomial, this piece, we get x squared plus 4. Our next piece, we're going to multiply these two polynomials. So we get x minus 2 and x minus 2. X times x is x squared. The next one we get a negative 2x, and a positive 4. Putting together our like terms, we get x squared. Negative 2 times plus negative 2 is a negative 4. So we get negative 4x plus 4. So this piece here becomes x squared minus 4x plus 4. And then one more set. We have a binomial times a trinomial. Let's see if I can put the work over here. So that would be a 2 by 3 box. So we get x squared and 4 times x squared, negative 4x, and a positive 4. Multiplying our boxes. Again, please pause the video to try these on your own. X cubed, 4x squared, negative 16x, and positive 16. Okay. Putting together our like terms, this will be our final answer. Our fourth degree only has 1, so that's x to the 4th. Our third degree also only has 1, so minus 4x cubed. Our squareds, we have a 4x and a, 4x squared and a 4x squared, so that's plus 8x squared. And then our x term is a negative 16x plus 16 would be our final answer.